And let's talk to the person that we always go to.
Oh, yes.
Dr. Lucy Jones.
Love having her
who is
here.
the earthquake lady. Dr. Jones, it's always great to see you. So Mike and I were just talking about the strength of this earthquake. And are we right that we haven't seen an earthquake in the Bay Area that has been of a 5.0 magnitude for quite a while?
Well, yeah, of course, it always depends on how you define the Bay Area.
Okay.
I think the Napa earthquake was the last one, a magnitude 6 in 2014.
Okay.
That would be close to that. When I look at I'm actually just pulled up the catalog listing, and that's right. That's only the Napa earthquake in the last decade.
Yeah.
Back in 2009. Oh no, that's too far west. So yeah, you haven't had this for quite a while. 2007, there was an Alum Rock earthquake, 5.4. That would be located very close to this one.
Okay, got it. So there are a number of people who, move into the Bay Area since then, and so this is the strongest shaking they would have felt, especially if they're living in the South Bay.
Oh, definitely, right. And it's you need to remember too that what they felt down in the South Bay is going to be quite different than what you would have felt in Berkeley or Oakland. I mean, just how far away you are makes a lot of difference. I'd expect that south of San Jose, you might have seen some things thrown off of shelves. That would be the shaking level you'd expect. Up in Berkeley, I would think you felt it and went, oh, wow, that was an earthquake.
And I have to say, just looking on social media, this is the first time in a long time that I've seen so many people talk about the fact that they have this Berkeley created app on their phones, which if you were living in San Francisco, it seems like a lot of people up here got that notice a few seconds before they actually felt any shaking.
Right. Well, the earthquake early warning system is run off of the network funded and operated through the U.S. Geological Survey, right? And Berkeley is one of the partners. Berkeley has put out this particular app to send out the information. But what you have is that the same seismic stations that tell us what the earthquake is are now able to give you the information so quickly, you can get it a few seconds before the shaking gets to your site. So in the Bay Area in San Francisco, because the waves had to travel up from south of San Jose, you would have had a decent amount of warning. But of course, if you were actually in Alum Rock, your shaking is what allowed the others to know.
So Dr. Jones, when something like this happens, we already did feel another smaller earthquake happen just minutes after the 5.1 magnitude earthquake. What can we expect over the next 24 hours or so?
You should expect more aftershocks. On average, the largest aftershock to a 5.1 would be a 4.0. Sometimes the 3.1 you've already had, that could be the largest one. 5% of the time, the aftershock will be larger than the main shock, and then we'll change the name and call the first one a foreshock. So you have about a 5% chance that there could be a larger earthquake on the Calaveras fault over the next few days. That's the sort of thing we saw in Ridgecrest. If you remember, in 2019, we had a 6.4 and the next day a 7.1. So that's obviously possible here. About half of our big earthquakes are preceded by some sort of foreshock, and it's a 5% chance of something larger going forward. Probably you're just going to feel, if you're down in Alum Rock, you'll feel 1 or 2 earthquakes today. If you're up in Berkeley, the Bay Area, you probably won't feel anything more. That's probably.
Hey, Dr. Jones, this is Mike Nico. I'm getting on some of my weather computers here. A 2.2 just happened at 12:02. Are you seeing that also? So another one that's near that?
I haven't looked immediately, but that seems not at all surprising. Let me check really quickly.
Yeah, just to the north of Highway 130, there should be looks like a smaller 2.2, so another aftershock.
Those are the 3.1 and the 2.2 are both aftershocks to the earthquake, and that's that USGS run seismic network giving you the information to come out here afterwards, but also sometimes if you're lucky, you get it a bit before.
How much time has to pass before we kind of feel like we're out of that danger zone of at least that initial earthquake?
We usually talk about 3 days. It's what's called a hyperbolic decay. It's 1 over time. So however many aftershocks you have on the first day, you'd have half that many on the second day and a third that many on the third day, et cetera. And once you've gotten out past 3 days, then you're probably, 95% of your risk is completely gone.
Yeah, what's up?
For those of us who are a little more novice, tell us about the Calaveras fault.
Okay, California is what it is because we're a plate boundary. We have the North American plate moving to the southeast compared to the Pacific Ocean moving to the northwest. The primary boundary is the San Andreas Fault. But you'll hear geologists, we usually say the San Andreas Fault system, because once you get up to the surface of the earth, it often splits up into some multiple branches. In the Bay Area, you've got a few major branches, the San Andreas that runs just west of the peninsula, and the Calaveras Fault and the Hayward Fault that run along the east side. They split off from each other around this area. The Calaveras Fault, of those three faults, is the least oh yeah, you're getting the right picture up in there. If you pull back a little bit, you can see how there's sort of those multiple strands. The Calaveras and the San Andreas are really part of the same system. And the Calaveras moves more slowly. It has less of the total motion going on there than on the San Andreas. So it moves less often or releases less energy. But it seems to have these small earthquakes a lot more often. It also creeps, which means it does move a little bit at the surface without an earthquake. So when we put a strain meter across the fault, we'll see this couple millimeters a year that go on. And then in addition, we get these larger earthquakes. It's considered capable of a 6.5 or so, 6.7. But unlike the San Andreas, it's not going to have a magnitude 8. When we say a fault is capable of something, what we're saying is how long a section of fault can move at once, because it's the length of the fault that moves in an earthquake that tells you how big that determines how big it is. So a 5.1, that fault was probably a couple of kilometers across, 1 or 2 kilometers. When we have a 6.5, you're going to be 15 to 30 kilometers long. And what that means is earthquakes don't happen at an epicenter, they happen over a surface. In a case like this, where the surface is only a kilometer across, an epicenter is not a bad representation. When you get to larger earthquakes, every point on that longer piece of fault is giving off energy. Back in 1906, with the 7.8 on the San Andreas Fault, that fault extended, the rupture extended all the way from San Juan Bautista in the south to Cape Mendocino in the north. And, Santa Rosa was as much on top of that earthquake as San Francisco was.
Oh, that's interesting.
Yes. So what things will you be looking for in the next few hours?
Well, the main thing right now is to say what's the rate of aftershocks. What we're seeing so far suggests that it's not a very active aftershock sequence. There aren't lots of little earthquakes going off. So increase the likelihood that we're just going to be dying off with time. I am sure that the USGS geologists are going to be heading out to the area to see if there's a surface rupture. So I said the surface is only a kilometer or 2 across. So, and if let's see, what was the depth on the earthquake?
7
kilometers. Yeah, so it's probably didn't make it up to the surface. Magnitude 5s very, very rarely have surface rupture, but you might want to go and check. And the part of it is, there's a lot of this that's random. So we got to just say, well, we'll see. Well, a foreshock is only a foreshock when a larger earthquake happened.
Since you bring that up, is there a correlation? Is there a scale between a magnitude and its depth and what we can expect? Is something like that developed, or is it too random or too, I don't know?
It's more that it's there's not a particular correlation. So the depth of the earthquake, when we look at it on the website, that's the depth of the hypocenter, exactly where it began. Now, if your fault is 10 kilometers across and it starts at 7 kilometers depth, it's probably rupturing up to the surface. And every point between that 7 kilometers depth and the surface moved in the earthquake. Rarely we see earthquakes starting shallow at a shallower depth and actually moving farther down. Mostly they start at the bottom of the rupture and propagate upwards. But we need to remember that just because where it starts, every point on that surface, as it moves, is releasing energy.
That's interesting because, we always talk about the depth of it, and, a lot of people don't understand what the depth actually means. I think they believe, if it's closer to the surface, there's going to be more shaking, there's going to be more energy release. If it's deeper, then you don't have to worry about it as much.
Well, there's a certain amount that's true, just because if it's deeper, you're farther away from it.
Right.
So, we don't often see really deep earthquakes down here, but like in Seattle, they'll have earthquakes that are maybe 50 kilometers down. And even then, a 6.8 Nisqually earthquake happened on, started down 50 kilometers, and basically most of it was down there below 40 kilometers depth. And so even though it was a 6.8 and it did do quite a bit of damage, it didn't have nearly as strong shaking at the surface as Northridge did, because everything was too far down.
Can I ask you another question? Because I think I explained well the difference between a slip fault and a thrust fault, and why our faults don't necessarily create tsunamis. Can you expand upon that?
Okay, yeah, and then we can wrap this up. A strike slip fault means that the fault is vertical and the ground's moving sideways during it. Whereas a thrust fault, the fault is dipping and moving up and over the event, over the other side. Because our faults are on land, it's very hard to produce any sort of tsunami at all, right? The only way to produce a tsunami is to change the shape of the sea floor. So you need to have a thrust fault underwater to be moving, changing the shape of the seafloor. And so in general, we don't have this down here. You need to go up to the Pacific Northwest, where they've got a big thrust fault offshore called the Cascadia subduction zone. The one exception is we can trigger landslides. This is way too small an earthquake to trigger a landslide. Loma Prieta, we did see a landslide in Monterey Bay, and a small tsunami that went along with it.
Landslides not happening, but book sliding, chandelier shaking, that for sure seems to be happening. Dr. Jones, I know you need to go. It's been really great talking to you. Such valuable information.
Thank you.
Thank you so much.
Thank you. Okay, great.